Macro-scale overview. We're observing an elongated upper-level trough stretching from the mid-Atlantic into the Eastern Gulf. This is our large-scale orchestrator of today's weather across the peninsula. At the surface, a quasi-stationary trough extends across south and central Florida, reinforcing moisture convergence. Meanwhile, a frontal boundary is sliding into northern Florida and interacting with this trough, anchoring convection from northeast Florida into Georgia. These features collectively supply ample lift, moisture, and instability to keep the region unsettled today. South Florida, Miami area. Water vapor imagery confirms the upper-level trough overhead with a surface trough and strong dew point gradient. Precipitable water, PWAT, is notably high, around 2.3 inches, placing us in the upper 10th percentile for mid-September. While clouds have thinned slightly, enhancing daytime solar destabilization, the setup is primed for an earlier and more robust convective onset along the Gulf breeze. Scattered storms are expected, moving northeast, but some may backbuild or train, especially over Broward and Palm Beach, potentially yielding localized rainfall up to approximately 4 inches. Key drivers: deep moisture, upper-level support, sea breeze collision zones, and easterly shear aloft influencing storm translation and training. Central East-Central Florida. The Great Lakes Trough continues shifting eastward, with a weakening high and collapsing cold front pressing into the panhandle, eventually stalling near northern Florida. Moisture remains unusually high, PW 2.0 to 2.2 inches. Sea breeze convergence later today will energize storms that may persist into the interior as the breezes collide. Anticipate frequent lightning, gusty winds, 40 to 45 miles per hour, and 1 to 3 inches rainfall, locally intense enough to cause minor flooding. Afternoon heat indices soar into the upper 90s to low hundreds. Mechanisms: sea breeze initiation, moisture pooling, front-enhanced lift, and slow-moving cells backed by deep moisture. Northeast Florida/Southeast Georgia, Jacksonville to inland Georgia. A frontal boundary drapes along the southeast coast and across northeast Florida, meeting the moist plume, PWATs near 2 inches. Sunshine this morning will destabilize the boundary layer, prompting showers and thunderstorms by early afternoon. Convection in Georgia is delayed until mid to late afternoon due to lingering cloud cover. A few strong storms may produce gusts up to 60 miles per hour and heavy rain. This setup is a textbook case of frontal convergence over rich moisture enabling diurnal convection inland. Slower convective motion coupled with high PW anomalies heightens rain threat. Georgia. Wedge, insulation, and local convection. An inverted trough offshore and high pressure building inland create a tight gradient. Enhanced coastal flow expected. Convection remains most likely over northeast Florida due to closer proximity to the trough/front axis. Elsewhere in Georgia, similarly to Atlanta, the influence of a cooler air wedge from the north and mid-level ridge suppresses most activity, keeping skies mild and dry, though isolated afternoon showers may form, where orographic lift promotes limited convection. Climatology and geography. In context, climate notes. Mid-September in Florida typically features high humidity, afternoon sea breeze-driven storms, and occasional fronts. Today is exceptional only in the persistence and anomalously high moisture content, approximately 2 to 2.3 inches PWAT. Geography matters. Coastal boundaries, especially sea and lake breezes, are prime locales for initiation. In northeast Florida, the frontal wave enhances inland propagation. South Florida sees interplay between Gulf versus Atlantic circulations. Georgia's terrain aids isolated afternoon convection in the north, but lacks the moisture punch seen further south. Mechanisms at work. Upper-level trough stalls over eastern conus, fostering mid/upper-level divergence and providing synoptic forcing. Surface trough/cold front interaction in N-central FL anchors convergence and lifts across Florida. Exceptional moisture, PW approximately 2 inches plus, fuels storm efficiency and potential flooding. Sea and lake breeze boundaries, especially along both coasts, focus convection, while inland collisions amplify inland storm development. Weak steering flow aloft, paired with veering winds, may result in storm training and slow progression, heightening rainfall totals locally. In Georgia, a wedge of cool air and high pressure from the north maintains more stable conditions with minimal convection, save for diurnal pop-up activity in mountainous areas. Today's summary. South Florida. Scattered to numerous thunderstorms, especially along sea breeze corridors. 1 to 2 inches are common, up to 4 inches localized. East Central Florida. Persistent moisture and front proximity yield afternoon storms. Watch for gusty winds and heavy rain. Northeast Florida. Sun-induced destabilization will spur convection by early afternoon. Strong storms possible